talking to myself, so you'll just bear with me. All right, it's recording, and I'll pull up our handy dandy book. And there we go. All right, now statistical tables and graphs, and like I said, this is where you see the first dummy down, you see frequency table. It's called a frequency distribution. So you need to write that down, because if you take another math course, especially probability or statistics, they're going to call it what it is, and that is a frequency distribution. And yes, you can call it a frequency table because that's all it is a table. But what I don't want you going into another math course and they call it a frequency distribution, and you go, what's the frequency distribution? And you know it's a table. All right, so you need to know both names so it doesn't catch you in another class. Now, what is a frequency table? Well, there's two types of frequency tables or frequency distribution. There is the quantitative and the qualitative. So we'll go to the white screen and I don't know if this is going to be distracting or not. Qualitative is going to be blondes, brunettes. You don't have to, I don't know if that's right or not. And redheads. These are what you call your classes. Well, I like to tell students, and this is just a personal preference with me, excuse me. I like to tell students to kind of keep it separated. A qualitative, you would have categories. And of course, this is head count. Now with quantitative, I'm just going to use an example, and I'm going to call it ages. Okay? They're called classes and head count. Okay? So if we talk about classes, then let's go with 10 to 14, 15 to 19, 20 to 24, 25 to 29, and so on. And 4, 3, 5, 6, and let's do the classroom. We got missing one person, I think. Yeah, we're missing one person. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got one redhead, one blonde, and the rest of us are what? Brunettes. So that makes us 8, something like that. Brunettes are so boring, aren't they? Oh, I mean, we're just boring. There's nothing. You don't see many sayings on Facebook that says brunettes are exciting, or what do they say? Blondes have more fun, and they have things about redheads, but never. I guess brunettes are just boring. Anyway, that's your categories and your head count. Over here, you got your classes and your head count. The main thing I'm trying to tell you is, with the qualitative and quantitative tables, you're going to have a category or a class, and you're going to have a head count. If you add the head count up, what do you get? The summation of x, which these are x's, is equal to what? N. The summation of x is equal to n. And of course, you can do your relative frequency by putting each one over your n. So 1 out of 10, 8 out of 10, and 1 out of 10. And that would be 0.8, that would be 0.1, and that would be 0.1, or 10%, 80%, or 10%. Now, the reason I'm going over relative frequency again is because that's a question on your test. I know it's in your homework, but I remember a question being on the test last semester. Will it be on this semester? Probably, because my tests regenerate and reorder and they pull from different questions. But that's one question I probably put on there because that is a standardized test question. What is the relative frequency? And the students will go by and not even do it because they don't know what relative frequency is. It's percentage. Okay? Same thing here. What is that? 5 and 3 is 8, 14, 18. So that would be 4 out of 18, 3 out of 18, and so on. I'm not going to do those because we're not out of room. All right, so that is a frequency distribution. No big deal. Just make sure you know what they are. And they're going to go through and talk about that. Yep, that's what they're doing there. Relative frequency, we already talked about that. Y'all sure I didn't go over this yesterday? I meant the other day. But see, I get y'all mixed up with the 120 because y'all going over the same stuff. So that's why I get sometimes. I remember talking about this. Y'all sure I didn't go over this? Must be another class. Okay, there's your qualitative data and your quantitative data. Qualitative data, categories. Quantitative data, measurements. And they give you examples right there. Brand names of shoes, that would be qualitative. Types of students, quantitative. And then the last one would be audience ratings of a film scale from 1 to 5. That would be qualitative. Because why? Those numbers really don't have any what? Mathematical meaning. If you can, and this is what I like to tell students, if you can add or subtract the numbers, the things that add, subtract, multiply, and divide, then you probably have quantitative data. If I multiply 2 times ratings of 5, I get a 10. Does that mean anything? In a rating system? No. Doesn't mean anything. Okay? All right, so anyway, that's that. And just use a lot of times you can go on Google and you can Google qualitative data examples. They'll give you a whole list. And quantitative data, and it'll give you a whole list, and that'll help you kind of figure out what's what. I wish they would put these things, well, doesn't matter, I can't go to both sides. And there they're doing the relative frequencies. Not worried much about that. There's a bar graph, there's a pie graph. You should know what those are. That's not, y'all been seeing those since your 3rd and 4th grade days and pre-algebra and stuff like that, basic math. So that's pretty much. Don't ask me why this thing acts up sometimes. I have no idea. We'll just blame it on the Russians. Okay, now we got a white page. More bar graphs. God, they wasted a lot of time in this book. More pie graphs. Now, read about this. This is on page 316. I will use Excel in the classroom. All right? There's a reason I do, and it's not because I'm trying to force it on them. All right, I'm not trying to force it on them. The reason I use Excel is because it lets me put everything on one board. I can set the type to 12 or the font to 12, and I'm able to get all the calculations on one board. There's no way in Hades I can do that with my writing. Okay, I go all over the place. Okay, and my writing is usually large enough to where everybody can see it, so there's no way I can get it on this board. I'd have to get it on 3 or 4 boards. And so that's why I do it in Excel, it kind of rations what I can put on one board. So that's why I use it. But I want you to read that because I want you, and it's very difficult to find a person right out of high school that can't use Excel. Okay? Most of the people that can't use Excel are people that haven't been around a computer, or as students say, haven't been in school in 1,000 years. Okay, so read about that, and we'll talk about that as we get toward the mathematical part. We'll do a lot of it in Excel. What's happening is this right side is really not calibrated the way it needs to be, and that's why the mouse is having a problem on the right side. Histogram. The difference between a histogram and a bar chart. You ready for this? Anybody want to take a stab at it? You're going to laugh. There's a histogram. Now, what's the difference in that and the bar chart that was on the previous page? Anybody want to take a stab at it?
There's no space in between the data.
Yeah. Okay, so it might stop the world from turning. Okay? You know, I really think somebody said, you know, I want to give a contribution to statistics, so I want to change the name of the bar graph to a histogram. I really do think that, because there's no difference between the two. One of them's touching and the other one's not. Is it something that's going to fail you in this class? No. But on a standardized test, would it get you? Yeah, if you didn't know what a histogram was. A histogram is basically a bar chart where the bars are touching each other. I guarantee you somebody in here didn't know that. But that's the big difference between the two. Do you read them the same? Yes. Do you draw them the same? Yes. You just don't have the bars touching. Now, somebody in here tell me the mathematical relevance of the bars touching each other. I don't think so. There's no relevance. In other words, mathematically, there's no difference. Now, you could say that there's a difference between the line graph and a bar chart because of presentation. But could you say that with the bars touching and the bars not touching? No. So I've yet to figure out a way that the histogram and the bar chart is different. So now, is there a difference between? Yes. This is used usually in most of your presentations. A lot of people can read line graphs a little bit easier. Now, they really like pie graphs. People love pie charts. They love them because they're easy to understand. Because, you know, when you were in grammar school, what did they tell you the first day of fractions? You have a piece of pizza. You have a pizza. And you cut it up into what? Slices. And that's the way people learned, and that's the way people think. So when you put a pie chart on the presentation, people usually just say, oh, okay, I know how to read that. The second most popular is the line chart. And the third is the bar chart, or the histogram. Capiche? Yeah, whatever. You know, y'all can talk, okay? Y'all can say yes and no. All right? The bar's width has specific meaning. That's their definition. I don't see how you can say a bar, the width of a bar has a specific meaning. Are they going to be different sizes? I don't agree with that one. And I'll show you how to do that in Excel also. Just for your information, not trying to convert you or anything. I'm just, those of you that want to use it can. Those are just different examples of bar charts and all that. Okay, finally, 5E. Hopefully we'll get into some math here soon. What page is 5E on? Can somebody tell me? Oh my gosh, look at that.
42.
That board, did you see that? The board's bass accurate. What number? I'm sorry.
342.
342? Thank you. When you look at that, the board's bass accurate. So the reason I pulled that up is I thought that it would show the classroom, but it's not going to do that because I don't have it engaged with another classroom. If somebody Skyped in, I probably would. There we go. How many movie people we got in here? Anybody love movies? Like watch them all the time like I do? Yeah. All right. The Matrix. The second Matrix. It's called Matrix Reloaded, I believe. Remember watching that one? They go into this French restaurant. They're looking for the gatekeeper. And they talk to this idiot that speaks French. And he goes on and rambles on about cause and effect. I drink too much wine. I have to pee. You remember that? Okay? And he goes into this long thing about correlation and causality. All right? Well, that's what it is. Does drinking too much wine or beer, in some cases, make you pee? Yes. All right? Correlation. There's a correlation between how heavy a vehicle is and the gas mileage. Yes or no? Yes. My truck, the red one out there, the redneck Cadillac out there, it gets 19 to 22 on the interstate. That's not pulling anything. That's not having stuff in the back end. Just me and somebody else or whatever, my son or whatever. Okay? Now, you take that same premise and you put it toward a Toyota Corolla or whatever y'all drive now. Okay? I'm not a car person. You're going to get better gas mileage because the car is not as heavy. There's a causality there. There's a correlation. It's a correlation, between gas mileage and the weight of the vehicle. And that's what correlation is. Now, I'm not going to sit here and ask you to find the correlation coefficient of I'm not going to do that. Because if you saw the math behind it, you would quit the problem. You wouldn't even do it. It's a very tedious. They give you and that's another thing I hate about this book. The more tedious the math, the more this book puts it in the student's hands. It blows my mind. Anyway, I just want you to tell me the steepness of it, meaning the slope. Remember slope back in algebra? And whether it's positive or negative, which depends on the slope. So all I'm going to want you to do is find the slope of the line, and we're going to go over that. So let's look at causality and correlation. And you're talking about probably a question on the test. A correlation exists between two variables when higher values of one variable consistently go with higher values of another, and vice versa. Okay? And you just need to say I drink too much wine, I have to pee. The more wine you drink, the more you have to go to the restroom. More. Those are two positive correlations. All right? Same thing with high gas mileage, higher weight of the vehicle, higher and higher. And they give you some examples there. Examples are always good. I don't go to a lot of examples except ones I just mentioned. Yep, there is a correlation. That's a good example right there. Height and weight. 90% of the time, or 80% of the time, there's a correlation between the height and the weight. Correlation between practice time, amen. And I don't want to put just piano players. I played the piano. That's one of those things that I wish I could go back in time. I wish I practiced more with the piano, because I think that's so great of a person being able to go into a room and sit down at a piano and play anything. I just think that's the greatest thing in the world. Or like a saxophone, or, you know, just an instrument. I wasn't born with that gift. All right, some of y'all were, some students are, but I wasn't born with that gift. I could have developed it. I could have developed my exposure to it. I don't want to say I'm gifted. My exposure to the piano by practicing more. But this is true with everything. You get out of something what you what? Put into it. I commend your parents for doing a good job. Usually I say that to especially a bunch of high school students. I go, that Patrick Starfish look. What is it? The orb of confusion. Slobbering on himself. Okay, you put out what you put into it, and that's the correlation there. Practice time, you don't suck. A lot of practice time, you don't suck. It's one thing I had to get to my daughter was worse, okay? But my son, he understands it a little bit more. My daughter, she wanted to play the piano. She thought she practiced 30 minutes, and she got mad because she couldn't play the piano like everybody else. And it took me a long time to get that into her head. And some people it take longer. But anyway, that's a good correlation. So it always helps to have some examples. I hate going over definitions. Scatterplots. Now, you don't have to write down the definition of a scatterplot. Most of you know what a scatterplot is. It's where you have a bunch of dots all over the place, and it looks like they're what? Scattered. Let's give you an example. And you just have to look at it. You don't have to. There's a scatterplot. Movies. Avatar. I don't get into the cartoon movies. I'm sorry. I have to watch them. It's called At Gunpoint with my son. The only cartoon I like to watch with my son and daughter when she was growing up was SpongeBob. That's it. But these movies, have you ever noticed that all these movies, these cartoon movies, have the same plot to them? Somebody gets lost, or somebody gets when they relocated. You get relocated or lost, and the whole movie is about them what? Getting back home or finding somebody. That's it. So Avatar, I don't know anything about it. Avengers, I don't watch them anymore. Dark Knight. The best Dark Knight movie was the one with Heath Ledger. That was the best one. He played the best Joker. Jack Nicholson played the best weird Joker. And Heath Ledger played the best Joker. I don't like that cat that's on that. What is it? Death Squad or... No, I don't like that cat. Maybe if he was in a movie all by himself, maybe. But just those few glimpses, I'm like, what's he got on his teeth? You know, he has something on his teeth. But anyway, Dark Knight Rises is good. Hobbit, I have no idea. Pirates, I never did get into. I'm not a pirate person, so I didn't get into that. Tangled, I have no idea. John Carter was about the dumbest dang movie I think I've ever seen. Okay, it ranks up there with some of the dumb. Name some dumb movies. Anybody know one? That should not have been made. Y'all don't have any. I don't believe that. I believe when you go home and you go after you see a movie, you say, "Well, that was dumb as crap," and you can't think of any.
All the new Transformers suck.
All the what?
New Transformers.
I never did get into that.
The first one was good, that's it.
Yeah, I never did understand the little wormy guy. What's his name?
Oh, Shia LaBeouf. That guy.
Is that his name?
That's his actual name, yeah.
Okay, well, I never did understand why they would be. And he always had these girlfriends that were like 10s, and he's like a 1/2. I never did understand that either. No, I never did get into Transformers. But you didn't like Transformers?
Not anymore.
Yeah. Anybody else got one?
My mom made me watch one like a week ago. It's like older and it was like stuck on you or something.
Man, I don't get into comedy, so I don't know much on that
It
one.
was like two guys was like born together and then they got separated. It was just like the
Oh,
dumbest
that
movie.
was stupid.
I just have
Yeah,
Wizard and
Schwarzenegger
Space
and
movies. I can't do those.
Well, see, I can't do, there's only a few comedies that I can do, and they have to be really good. Like some of y'all may remember Eddie Murphy. Now, Eddie Murphy was classic as far as doing a comedy movie. I know y'all gonna say that I'm crazy, but Will Ferrell gives me the creeps. When I see his face, I just want to cringe. All right? I have to go out of the room when my daughter or son watches his movies. He creeps me out. So his, you ever feel like that about an actor or actress? Just, ugh.
It's like Adam Sandler.
Who? Now he is funny. That guy is funny. I love Anger Management was one of his greatest. I laughed during that movie, but Jack Nicholson helped that. That movie would have been nothing without Jack Nicholson. But any of those guys a dumb movie?
Bad Grandpa was dumb, but I liked it.
What?
Bad Grandpa is dumb, but I liked it.
Never seen it, never heard of it. What is it? It's a comedy?
No.
It's like it's a young guy dressed up as an old man, takes like the psych.
Chowder. Yeah, one of the reasons I don't like comedies now is because they're not creative at all. It's usually 5 or 6 people going out and getting drunk, they can't find their way home, or they lose their car, or they're just not very good. Anyway, I'll shut up now. All right, now, the whole point about doing one of these is you got to find the line that says least progressive. All right, the line that matches up with all of them. Okay, now that's going to be hard to do because you're going to have a line that goes all over the place. Well, you have to eyeball it. All right, now the one good thing about your calculator is your calculator will do this for you, and I'll show you how to do that. All right, I'll also show you how to do it on Excel. All right, when we get there. But if I was to eyeball this, I would probably put the line somewhere in there. Okay, now it takes practice. I mean, you have to look at it. You just can't say, you got to look at it and say, okay, well, if you throw out the one outlier, where would the line go? And you say, okay, well, let's just throw these 2 out. And then you would see it a little bit better, okay? And that's called the line of least regression. You're going to see it probably in a page or 2. Least regression. In other words, what does electricity and water have in common? Come on, you electrical people. What do they have in common? Oh, God, y'all suck.
Water conducts electricity.
No, but that's right. That's good. But they have in common. What do they have in common? Both of them do the same thing. Follow the path of least resistance. Okay. So this is when you think of regression, think of kind of like resistance. Think of where is the easiest path with these dots. Okay. Now that's the kind of thing I will ask you on a test. I will ask you to draw a line. I will ask you to say what's the slope of the line. I will ask you if it's positive or negative. How do you tell if it's positive or negative? Which way do we read?
Left or right.
Unless you're from Middle East, Masalama. If you're from around here, you put a car on the left-hand side. And what is that car doing? Going uphill, so that's positive. If you got a line going like this, throw a car on the left-hand side. What's that car doing?
Going down.
That's it. It's easy as that. You'd be surprised at how few people can make that difficult. All right, don't. You read from left to right, put your car on the left-hand side, what is it doing? Okay, so that's a correlation right there. Now, is there much correlation here? Well, yeah. But I don't even know what the category is or what we're trying to actually, probably price of the movie.
How much they gross?
Okay.
Production.
Okay, cost and okay. So this one Avengers cost $225 million, but it brought in $650 million. John Carter, which was stupid, cost $300 million and brought in what? I bet some people got fired on that one. Or they didn't get picked back up the next year. John Carter, you never seen it? It's about this Confederate soldier that gets transported to Mars and fights for the Martians. It was one that, you know, when you have this sci-fi binge and you go on sci-fi and you watch all the cheesy, well, I love those movies. They're so funny. They have the terrible acting, and just whenever you get a, you know, you want to watch stupid movies, go to sci-fi, especially when an Anaconda versus Sharknado and all this other stuff. Anyway, go there. You'll see John Carter. It's really stupid. All right. There's cheesy, and then there's just dumb. Yeah, the terrible acting is just, the sci-fi movies is just, there's Swamp Shark versus Anaconda, and then there's Lake Placid, the big alligator versus Anaconda, and then there's, the best one is where they mix a octopus with a shark, and he terrorizes the whole city and all this stuff, and the acting, the computer graphics is terrible, but people watch them because they're so cheesy. I don't know. I guess people watch soap operas, and nobody has a job in soap operas, but people watch them. You ever notice that? People never have a job, and they always have the week off, or they always have vacation. They never have a job. Maybe that's why so many people think they live in a fantasy land. Okay, next. Types of correlation. Well, there's not really. There's positive, and there's negative, and then there's none. That's it. Look at here. What's this one? Well, you could draw. What's that one?
Positive.
And this one?
Negative.
There you go. Now, if the one on the left is positive and the one on the right is negative, what would one that has no correlation look like?
Wobbly dots.
Straight line going which way? Left to right. Think of it as a slope. Remember, slope? A skier. You put a skier here, he's going to have to actually work, or the car, or the skier, whichever. He's going to have to work to go uphill. If you put a skier here, he's going to what? He's going to go downhill. But if you put a skier on this, he's not going to do anything. He'll have to work to do anything, but the whole point is the slope of zero. Remember, slope of zero is a horizontal line. When your slope is equal to zero, you have no correlation. Zero, no correlation. There's the type of test question I would give you on a test on chapters 5. I think chapter 5, yeah. Okay? Still doing definitions. No correlation right there. So you might want to make a note about that. Page 346, no correlation. Accuracy of weather forecast. Well, this must not be local news, because local news wouldn't be. Local news tries to scare everybody to death, okay? That's why I don't watch it. I watch the national news. Okay, they say, okay, there's going to be a blizzard, and it's going to come through South Carolina, and it's going to go through North Carolina, and it's going to hit New York, you know, very hard. We're going to have a blizzard in New York. And they say, it's snow flurries in South Carolina and North Carolina, and then as it gets across Virginia, it's going to really get into a blizzard. Oh my gosh. The local news, oh my gosh, go out and get supplies. We're going to have a flurry, but it's going to freeze and you're going to run in a ditch. I mean, it's just awful, so I don't watch local news. So anyway, that's the correlation. You got a positive correlation here. Let me ask you something. Is this correlation different than this correlation? Not really, but the steepness may be different. And that's where the slope comes in. Okay? But they're about the same. You got a positive here, and you got a positive here. You may have a difference of of a point or two or a tenth or whatever, but the angle is still going to be the slope. Okay? I could not be an English teacher. All right, write this down. This is on page 348. What are possible causes? The correlation may be a coincidence. And that's usually not the case, but it can be. All right, both variables might be directly influenced. And one of the correlated variables may actually be the cause of the other. That would be the weight of the vehicle having less what? Gas mileage. Okay? So write that down because that could be a question on a test. Oh, I get tired of doing this over and over and over. Oh, and you just have to write coincidence, influence, or correlated. Okay? And that's on page 348. Sorry. We're getting toward the end. This is probably where they bring in the correlation coefficient. No, good, we're out of there. All right, now look at chapter 6. What do we do in chapter 6? Do we do all of them or do we do some of them? Look at the outline. Huh?
A, B, and C.
A, B, and C. So let's go to A. Somebody tell me what page 6A is on, please. 3 what?
62.
Thank you. All right, let's move into, I'm going to the whiteboard now because we're fixing to get into math and I can really go fast now. All right. So, in statistics, what's the first thing you do? You put your data in order. Okay, and then after you do that, then you're going to be asked for several things, but we're going to do a blanket. Okay, we're going to get the mean, median, mode, range, mid-range, variance, and standard deviation. Now we're going to go ahead and talk about how to get these things while we're on the whiteboard, and then we're going to do some problems, and I'm going to pull up the Excel spreadsheet, and we're going to see actually, how we do it. So the mean, and you did this back in grammar school or high school or whatever, whenever you wanted to find your grade, you add up all your test grades and you divide by how many number of tests. Well, that is the summation of x over n. Now, if you want to write it different, say add up all the numbers and divide by how many numbers. If you want to put that, that's how you write it. When I say the word median, and you're not a math geek, what do you think of?
The middle.
Middle. Why?
Because the median is in the middle of the road.
Exactly. The median is the middle of the road. So, when you see median, that's the middle. Now, you got to make a note on this. If n is odd, you just pick the what? You just pick the middle. If n is even, you've got to find the average of the two what? Middle what? Two middle terms. And y'all should know that from, you should know it from somewhere in grade school, K through 12. All right, you should. All right, but we'll do it. Find average of middle two terms. Okay. Mode. Remember MO and MOST. It's the number that shows up the what? The most. Now, can you have more than one mode? Yes. The only one that really doesn't have any mathematical meaning is the mode. The mode is the only one that's not calculated. The mode is the only one that's observed. Is there any use in the mode? Not really. Okay, but the high school, the homework's going to ask for it, and the tests are going to ask for it. So you need to know how to do it. You can have one mode, you can have two modes, you can have three modes, you can have five modes. Okay, one mode is called monomodal. I have to really say that slow. And then there's bimodal and trimodal, and then polymodal. That's just for your information. But there's two things you need to remember. Yes, you can have one. So if you have more than one mode, write all the modes down. If you have a number that shows up twice and you have another number that shows up twice, you write both of them. Okay? If you have one number that shows up 3 times, and another number shows up 3 times, and another number shows up 3 times, you write all 3 of them down. That's one thing. The next is never use 0 as an answer. Anybody ever had a smart aleck teacher? Now, when I mean smart aleck, I mean when you got a problem wrong, they'd either put some kind of snide comment on your test, or they make fun of you if you got a wrong answer, like in class. You ever had one of those? Well, sometimes students will put 0, meaning there's no mode, and the smart aleck teacher will go, 0 is not even in the list. 0 is not even in the data. And they'll mark it wrong. So don't do that. Put no mode, put NA for non-applicable, put ain't none, ain't none, whatever you want to put, but do not put 0. Okay, that's just something I've seen happen before. We had a teacher here that would do it. And they're retired now, so. Range. Your highest minus what? Minus the lowest. That's pretty simple. If you miss the range, you don't tell anybody, okay? Because that's pretty much the easiest. Besides the mode, that's the easiest one to get. Mid-range. Same thing as midpoint. Your highest plus your lowest divided by what? It's the average of your highest and lowest, your min and your max. Now we're going to hold off on variance and standard deviation, but I'm going to write the formula down, so hopefully it'll intimidate you and you'll drop it. No, I'm just kidding. But the formula for the basis of variance is equal to the summation of x minus x bar squared over n minus 1. Okay, that's the basis for both of the formulas, and we'll get into that a little bit after we do a couple of problems, okay? Now let's look at an example. Let's do something simple like test grades. 92, 78, 90, 82, and 76. All right, write those down. First thing you want to do is put them in order. Now, you can use your calculator, but I'm not going over the calculator yet. So if you don't know how to use the calculator, don't even get it out, okay? I'll go over that last when I put it on Excel, and I'll show you how to use Excel. So everybody should be trying to do it by hand, okay? Trust me, I've been doing this a while. The easiest way to get this across to students is to do it by hand, then by Excel, then by the calculator, and they learn it a whole lot better. So the first thing is put them in order. Well, 76, 78, 82, 90, and 92. All right, now let's add them all up. Now you might need your calculator if you can't do basic math, but you should be able to. So 8 and 2, that's 10, 16, 18. Bring you 1. That's 10, 19, 27, 27, 34. Somebody help me out. What'd y'all get? Huh? Okay, remember, don't knock on the door like this. And you don't answer questions in my class like, okay, enunciate and volume. Okay, it's 348. What y'all come up with? Okay, are y'all even cognitive of what's going on or what? Check it, because I did it in my head and I did it quick. I just saw a question look on somebody's face. What'd you get?
418.
Okay, I did something wrong. I suck. 418. That's why you need to do it slowly. What'd you get? 418?
Yes.
All right, so now we take 418, our mean, which is also your average, which is also X bar, which is also mu, is equal to 418 divided by 4 or 5. 5 divided by 5. And that gives you 83 something?
83.6.
Okay, so there's your X bar, your average, your mean, your mu. It's not mu because we're doing a sample. Because there's one student's test grades out of the whole group. So it would be X bar. Okay? Median. Well, how many we got? 1, 2, 3, 4, 5. So median is odd. I'm going to put a note here, odd. Therefore, median is equal to the middle number, which is 82. Mode, NA, none. Range. Range is 92 minus 76. I have no idea. What is it? 15? 16. Enunciate volume. Okay? Range, mid-range. Well, that's going to be 92 plus 76 over 2, which is going to be 168 over 2, which is equal to 81?
84.
84, sorry. Okay. Somebody tell me what that tells you. See if you were taught probability and statistics in high school correctly. What do those numbers tell you? Okay, I'll suck again. Nobody's going to tell me. All right. Some of y'all may be mechanical. Some of y'all may know. I'm just going to show you a picture of something. Let's say this is a bearing. Man, it's in a housing. Some of y'all know what a bearing is, some of you don't. But I'm going to explain it. And you got an axle, a rod. And that rod's attached to another bearing over here. And there's a roll of something on it, and it runs at 2,500 RPMs. Somebody tell me what the function of the bearing is. Anybody know? Okay, the function of the bearing is made up of two metal pieces. It's got little ball bearings in it or roller bearings in it. And you're supposed to keep it greased, lubricated. And it's able to turn that rod at high RPMs. So you can, like, you ever been to a fabric industry where they have these big rollers of fabric, and they undo those rollers, they take them off, and it runs at a high speed. Okay, it's able. Your car has a bearing and an axle. All right, your tire turns. There's no telling what the RPMs on your tire is on the interstate. Okay, so what does the bearing do? It keeps that rod from wearing a hole in the wheel, okay? It just turns. Those rollers sit on there and turn. Now, in order for the bearing to work, the bearing has to fit very tight on the axle. Anybody know why? There'll be no play. That's a good word. You're going exactly where I want you to go. You can't have, if you have a bearing, here's the bearing. The bearing is made up of rollers in there, and they're real shiny. You ever heard of ball bearings? Okay, slingshot, knock windows out with, okay? Little ball bearings are real shiny. That's what's in there. Or some of them are roller bearings. Rollers, like rollers, they're squarish, and they last longer. Anyway, they're in there. It's about, in a size like this, there's about 20 roller bearings in there. And the rod fits right in there real snug. Okay? Versus, let's say you just put a bearing in there like that, and the rod is right here. Now, that rod is going at 2,500 RPMs or 1,500 RPMs. Do you know what a metal rod or axle will do to you if you stand at the end of it and it's going like this? What's it going to do to you? It's going to beat the crap out of you. Well, what's it going to do to that bearing? It's going to beat the crap out of it. And it's going to end up just tearing the whole housing up. Versus, and that's play. There's a lot of play there. Like she said, a lot of play. Some people call it this. You ever heard of slop? Not what you feed pigs. But you ever heard a mechanic talk to you about your brakes or your bearings or whatever? There's a lot of slop in there. There's a lot of play. And it's not good. Versus a bearing fitting really what? Tight. What in the heck does this have to do with numbers? Well, if these three numbers are fairly close together, your data is what? What do you think it is? Is it tight or is it sloppy or a lot of play? It's tight. If these three numbers are close, I'm saying within 3 or 4 points of each other, okay? Then your data is what we call valid or tight. Meaning what? To you as a statistician or to you look, if you're an employee at work and you're looking at the mean, median, and mid-range and they're close, what is it telling you? That the data that they're using is what? accurate. It's valid. They didn't go out and survey a bunch of grandmas or a bunch of kindergartners. Okay? They went out and they got a good pool of people to survey, or their data on how many dead bodies are coming out of 2 North, or how many bad tires are coming out of Michelin. Their numbers and their data is valid. Versus if you see a mean of 75, a median of 106, and a mid-range of 42. That tells you, as an observer of the presentation, or as a student, it tells you that that data is what? Sloppy. That's what those 3 numbers tell you. Capiche? Now, let's talk about the mid-range. I meant not the mid-range. Somebody tell me what time it is so I can keep up with the time. It's what?
22.
Oh, I thought you said 20 after. I was like, dang. Time goes by when you're having fun. Y'all are like, yeah, right. The reason I'm not going to another screen is I don't feel like copy and pasting, and I don't feel like trying to memorize those numbers because I have no short-term memory. So I'm just erasing this and just using this board again, okay? Now I'm going to find the variance and standard deviation. So the formula for variance and standard deviation, there's only one thing you have to do to it to get the standard deviation. Is the summation of x minus x bar, quantity squared, over n minus 1. And what do you got? Well, this right here, what did I tell you that n was? I told you that the formula for n is equal to the summation of what? To get n, what do you have to add up? All the what? I gave it a letter. What was the letter? X. Remember? 2 or 3 pages ago in your notes? Yeah, I remember, Hubert. Okay, so equals the summation of what? X. So what is each one of those test scores called? X. Your first test score is called X of 1. Your second test score is called X of 2. So you've got, I'm going to just write it over to the side because you can call them all X's if you want to, but that's your second test score, that's your third test score, your fourth test score, and your fifth test score. When you have a subscript like that, that means there's no mathematical relevance to that number. It's just there to show you it's the first one, it's the second one, it's the third one. All right? So these are all X's. So what have I got to do? Read. Now this is one thing that I really stress in my probability courses. Most of the time, if you read the definition or if you read the formula, it will tell you what to do. I get so many of these students, I'll put the formula on the board. 5 seconds after I put down the test scores, they'll say, what do I do to get the standard deviation? They don't even read the formula after I say that each one of them is X. So what does the formula say? That's not rhetorical, I'm asking y'all.
The sum of each number.
Okay, what? Okay, this is sum, yes. That means you add up. What?
Each value.
Okay, each value minus what? Okay, each value.
And then square it.
Good. You're reading. You're doing what you're supposed to do. Minus the mean. And then you take that number and square it and divide by n minus 1. Okay? So you have to read the formula. So what have I got? Summation. Have I got summation? No, I haven't got summation yet because I got to do what's in the parentheses. Remember the old adage, do what's in the parentheses first? Okay, well, X. Okay, I got X. But I need to subtract what? Give it to me again.
83.6.
I'm going to round it to 84.
Okay.
because I don't want to have to try to do that in my head up here. Okay, so minus 84, minus 84, minus 84, minus 84. It's another reason I do it in the Excel spreadsheet. Now you would minus 83.6, but for instructional purposes, let's just change the mean to 84, so everybody will be on the same sheet of music. All right, so I'm going to call this column right here, because I want to make a column for this. We're going to call this x minus x bar. 76 minus 84 is negative what? Well, 14 minus 6 is 8, so it would be negative 8, right? 84 minus 78 is what? 14 minus 8 is 6. 82 minus 84 is negative 2. And 90 minus 84 is 6. And 92 minus 84 is what? 8, Hubert. Thank you, class. Appreciate y'all's interaction and y'all being aware of what's going on. Okay, now what are we going to do? We did this. Let's highlight this. Let's color it green. That means we've done it. Please excuse my dear Aunt Sally. Parentheses first, then exponent. So I've got to make another column. Now the good thing about the Excel spreadsheet, and some of you that use the Excel spreadsheet, you're going, oh, I see why you use the Excel spreadsheet now. Yeah. Okay, because the Excel spreadsheet will do it for you if you put the formula in there. So I'm going to take this right here, and I'm going to what? Square it. So what's negative 8 squared? 36, 4, 36, and 64. So now I've done this. Now, what's the only thing left to do in the numerator? Nope. No. Numerator. What's the only thing that's not highlighted? Summing it all up. So I'm going to take my handy dandy calculator and I'm going to add all those up. Well, you can add 2 or 3 up real easy because 4 and 36 will give you what? 40, and you can add 40 and 64, that's 104. And then you can take 104 and add to 30, that's 140, and then 204, somebody check. I do better when I'm not drunk. Oh, I'm sorry. I got a red Solo cup. Did I tell you about that teacher? Red Solo cup. Every morning, 8 o'clock. And would go out to the car after and come back in and go back out to the car. So by the time 1 o'clock rolled around, he was buzzing. I'm sorry, but if you're drinking at 8 o'clock in the morning and you don't work third shift, you got issues. Especially hard liquor. What do you get? Oh my gosh, Hubert's sober. 204. So now there's my numerator. Now, you got to really do the hard math. N minus 1 is what? 4. So our variance is 51. Mathematical meaning? None. You can use your variance for later on in probability and statistics, but as far as basic statistics, it doesn't tell you much. Standard deviation is your most important number besides the mean. And how do you do that? Standard deviation is equal to the square root of the what? Good job. How'd you know that? Just probability and statistics. All right, so, okay, 51. I can't take the square root of 51, even though the square root of 49 is 7. 7.1, 7.2 maybe? I'm going to go with 7.2. Somebody tell me what the square root of 51 is. 7.1 what? Okay, that's close enough, 7.2. And the reason I say that is I would much rather you think about it in your brain than use the calculator, because now, if it was the square root of 57, that would be different because that's away from 49, but you could do square root of 49 square root of 64 and interpolate and get it in the middle. You could do that, but that's good enough for government work. Now, what are the two most important numbers in statistics? Take our handy dandy red highlighter and we're going to highlight that number and we're going to highlight the 84. In statistics, the two most important numbers that you can calculate is the mean and the standard deviation. What's the secondary important numbers? Your median and your mid-range. Other than that, the other numbers are worthless. Okay? So, as we finish today, I have no idea what time it is, but as we finish today, I want you to really focus on those numbers. If you can't find the range, you don't tell anybody. If you can't find the mode, you don't tell anybody. So just focus on the numbers that are important, okay? You should be able to find the range and the mode without much thinking. But who's got a question on finding? Now you can put this on an Excel spreadsheet. It's a whole lot easier, especially to present. Yes?
It might be a dumb question, but why do you have 76 minus 84 or 78 minus 84?
That's x minus x bar. This is x minus x bar. I'm actually doing the process. This is x minus x bar. I'm starting the process. Okay? I'm starting it. I have no idea what this thing is doing. I'm starting the process here. I'm putting it in on the board so you can see it.
I thought
This is the product.
It was the n is the summation of x was that for some reason.
I'm sorry, say again?
The n is the summation of x. Since it's up above it,
Yeah, here's n right here.
No, the little formula that's up at the top.
Yeah, that's this right here. I was saying what is n, and I was trying to show you that these are called x's because this is the summation of x equals n. That is the summation of all your what? X's, and then I said these are x's. In other words, yeah, and this is the actual start of the process. This is the product of the process. So you don't necessarily have to put that column in there. I just did that so you would know what to do. All right, who has another question?
Do we need to know the super long standard deviation formula where it's you have take the square root of x minus x bar squared, then it's plus, and it goes all the way out over n minus 1?
Where do you see that?
Homework 60.
Okay, they're showing you the.
Yeah.
They're showing. Just ignore that.
Okay.
This is how you do it.
Okay.
What they're doing is they're doing away with this column, and I don't do that because if you use an Excel spreadsheet, what are you going to see? Columns. So to me, taking away the columns is kind of counterproductive to teaching students how to use Excel and do it by hand. What is your TI-84? What does it use? Columns. So teaching without columns is kind of counterproductive, so I ignore it. Okay? And this might make a little bit more sense. All right. Now, let me go here and see. Oh, we got time. It's 10:53. We only need 15 minutes. So let's go ahead and, what time's class over?
11.
Oh, 11. I'm sorry. Then I'll shut up then. Okay, y'all got enough to go on now. Now, what section is this? 6 what? 6A. So that means tonight you should be working on 6A. Now, some of you, I think you sent me a couple of questions. The reason I didn't cover them today was because I just went over that material. So tomorrow, when y'all come back, when's tomorrow? Monday. I will go over those questions because chances are everybody else will be sending me questions on that too, and we'll go over it one time. All right, pass this around. I want to get one more day, and then no, this is our last day, because this is y'all's second week, right? Yeah, this is y'all's second week, even though, I'll shut up. Today is what, the 24th?
Yeah.
Well, I'll call it, because I want to learn y'all's names. So if I stare at you for about 15 seconds, I'm not curving, just trying to learn y'all's names, all right? All right. Ashley. Okay, so that's Miss Ashley. Some of y'all's first names kind of screw in my mind, all right? Especially some of y'all, well, now it's guys. Because guys are now getting names that are, I can't tell if they're a guy or a girl, not because of their physical, but because of their name. So I have to look up first. So Miss Ashley is here. Bays, Mr. Bays. That's you, right? Collins. Okay. Gregory. Okay. How do I know that name? Gregory. I know that name for some reason. Have I advised you? Why do I know your name?
Sheila.
Okay. You've been referred, haven't you? All right. Harvey. Okay, sorry. Hayes. I'm trying to remember y'all like H-N-H. I have to do a lot of association because I suck at names. I can't see these lines. Kirkus. Is that Greek? German? Oh, it's not an OS. Duh. Sorry. Something I watch all the time. Have y'all seen, and I'm a Discovery History Channel nut, okay? Have y'all seen the recent thing about Adolf Hitler and oh my gosh, a lot of people think that Adolf Hitler died and that was it. No, it wasn't. That man was wanting to incinerate New York. I'm talking about with a nuclear bomb, and he was working on a nuclear bomb in Norway. And that mug did not die of suicide. He did not die of suicide. He died somewhere in the world. I mean, they have proof that he didn't die. But nobody knows that.
Proof that they found him and Eva Braun underneath Berlin.
They said that they said that the dental records was not conclusive. And then they have proof of him being in other areas of the world after he was supposedly been dead. CIA
People
files.
still see Elvis and Tupac.
Oh yeah, that's true. But this is CIA. They do have documents from CIA that has it on there. It does. It's just interesting. I think it's interesting. But so is I watched the other show. It's called The Legend of Oak Island. I watched that too. That's interesting. If anybody don't know about it, you need to Google it. Mr. Lowry is here. Neely. I had you before. Look familiar, or your name's familiar. Richardson. Okay. And how do I know you? I know you somehow.
Through Jennifer and Christina.
That's it.
Probably.
Yeah. For another referral. And Miss Blackwell is not here. All right. Do y'all have any questions for me? Because I think I'm okay. I don't know. I got 7 minutes, right? What time is it? 4 minutes?
10:57.
Okay. Anybody got any questions? All right. So everybody is responsible now for 5A, 5C, 5E homework. And you're supposed to be working on the weekend and before Monday, you're supposed to be working on 6A and sending in questions on any of all that. Okay? Y'all get out of here and have a good weekend.
Did us missing any class alter the test schedule?
I'm sorry, what?
Did us missing any class? This is classes alter the. Okay.
Like I say, we got 10 to 12 days that would be taken up by tests and stuff. I'm not worried about that.
All right.
Well, we'll probably finish early.
That's fine by me.
Have a good weekend.
Take it easy, bro.
Gotta shut off the Sometimes I forget to shut off the recorder. 3 classes